Welcome to Study Loop.
So we need to solve this problem in two steps. So for the first step, what we need to do is we need to find what is the speed at the end of this ramp. So let's first start that. So we know that initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. And the initial potential energy, since this guy's here at the bottom, is 0, therefore we can say that 1/2 m times 5.4 squared is equal to 1/2 m times v squared plus m times g times 0.4. So we can cross out the m's because every term contains m, so we're basically dividing every term by m. And when you solve this equation for v, we get v is equal to 3.56 meter per second. Now beyond this point, the motion of the particle is going to be projectile. And in projectile motion, we remember that the horizontal component of velocity, which is v cosine of theta, that remains the same. So at the highest point, the velocity would be v cosine of theta. So now for the second part, we will analyze this part of the problem. So this part was done only to give me the velocity at the end of the ramp. Now I'm going to apply again k sub 0 plus pe sub 0 equals k sub f plus pe sub f. And now for this part, I'm going to say here is where the starting point is. So at that point, I know that the kinetic energy is 1/2 times 3.56 squared, and I can take the potential energy at that point to be 0 with reference to the point at the highest point, and then that's going to be equal to 1/2 times m times 3.56 cosine of 48 squared plus mg times h. Again, to simplify things, we can get rid of all the m's, and when we solve this equation for h, it comes out to be equal to 0.29 meter.